set the recording and hand it over to Kevin.
All right. Hello, everyone. Welcome today. And we're going to talk about compute within the Globus ecosystem, computing across distributed resources with Globus. Hi, I'm Kevin and Reed. So just to kind of give you a lay of the land about Globus in general, compute is one part of that, a relatively new entrant to the Globus platform. But I think I knew Globus before I joined Globus as really good at transferring data from one site to another site robustly, lots of files, large and small, and on repeated fashion. Very cool Globus transfer. But there's lots of other things that Globus does as well along those lines in terms of sharing data. You might have lots of data stores or some groups of people, some researchers have access to this data, that data, and how do you make it quickly and easily available in a robust and secure fashion? Globus has your back there. Globus auth underpinning all this and so forth. But we are talking today about managed remote execution, which would be our Globus Compute. So the backdrop of where Globus Compute kind of came from is a recognition that not all problems are the same, and the economics approaching these problems have changed since 20, 30, 40, 50 years ago. Now you might have a large data collectors, say the APS is a good example, taking laser interferometry pictures, snapshots, and need to compute and handle those right quick now with certain dedicated platforms. Or you might have a smaller set of data, say, or Arduino taking data measurements from out in the field. And do you want to process these with your ASIC or FPIC processor, or a CPU, general processing, or maybe on a GPU for vector processing? Who knows? But the point being is we've got lots of ways of computing it, and the issue is where to do it, how to do it, and to what do you have access. So, recognizing too, in the same vein of where your users and expertise lie and what resources you have to utilize. So you might have cluster at your access. You might have just a couple of desktops. You might have a Beowulf cluster from 20 years ago. You might have a couple of Raspberry Pi processors to do what you need to do. And you've got users who have a diverse set of experience in the biology and in sciences and in sociology. Who knows? But the key detail is how to remove what I do as a computer science, I'm going to call myself a nerd lovingly, from what researchers want to do, which is just work on their codes. What happened? Sorry, I'm having an issue. Technical Zoom is messing with me. There we go. So our approach is to try to move to where researchers are and remove some of the low-level plumbing. Low-level plumbing being like, I've got access to a powerful computer, but I've got to do this thing called SSH. What is SSH? That's a really powerful, awesome tool, but secure shell means nothing or only as a roadblock or a speed bump on getting my work done on some other environment where I just want to compute. And we offer then function as a service compute. The idea to, you can write your function in whatever way fits best for your workload and work on it locally on your own workstation. But then you can wrap that up, send it across the wire with Globus Compute to another service, to another resource, which will then take that function, not the entire file, but just that function out of memory into another machine's memory, and you can use that to process your codes on all of your arguments. In short, function as a service. Globus Compute, which I said a couple of times, and kind of cart for the horse here. The idea is you can use any resource to which you have access to run compute functions. So if you have access to your own laptop, that's fine. You have access to a desktop at home while you're at work, fine. If you have access to a department cluster, you can use that too. If you have access to leadership class supercomputer machine, you have access to that too. All the same, you work on it. The idea is you work on it locally in your own workstation, get the function work the way you want to, and then fire it off to much more powerful resources wherever you have them. So, compute. What it is hard to explain, but we'll break it down to three roughly parallel segments. You've got I'm going to work from the bottom to the top, from the compute SDK. That is roughly your laptop, your workstation. You use the compute SDK to package up your function and use the compute SDK to send it to our service up top there, the compute service, which will take the task, take the function serialized, and then we'll dole it out to different endpoints to which you have already pre-set up access or another administrator has set up access for you. Either way, you send a task from the SDK, your workstation, to the compute services, what we manage, and we send those along to the endpoint, which is back to something you have access to somehow. Either you own it or somebody else manages it for you to do the processing, and it sends it back. Three components to keep in mind when thinking about compute: you, the remote, and us in the middle. So, from most researchers' point of view, you have some functions. Say you want to stupidly add two numbers, 3 and 7, or whatever arguments you want, or you want to do some heuristics on images you're collecting from your microscope, or you want to do some simulation. These are your functions. What you want to do, you give that to the SDK, which will then serialize the function, and you give it a number of arguments, and it will send those as tasks to the different resources to which you have access. At one, you send them off the SDK. The Globus Compute service takes those and doles them out as your SDK requested to the endpoints to which you have access, in this case, A and B in this image here. And then your SDK/you sit there and wait, and the resources or the results come back after the endpoints are done processing them back to you. And the point being is you effectively never left your desktop. Again, this crafty SSH tool or logging a remote cluster or dragging copying files, largely taken care of for you. That's the idea from the researcher's point of view. I think at this point, I will turn this over to Reed to talk about some of the fundamentals of how we use this when coding via the SDK. Back to your workstation.
Okay, I'll take over here. I was actually just writing up a response to the chat there, but Kevin, you can maybe grab that.
I didn't even see that. Thank you. I will.
Let's see here.
Do you want me to? You want to take over the sharing, or do you want to have me type through for you?
Well, because I'm going to be going over to the Jupyter demo, I think I need to share.
Go for it.
Let's see. Okay.
I will stop sharing.
All right, just going to go to this here. So I'll do a quick little overview of using the SDK. So this is obviously from the perspective of the researcher submitting to an endpoint, and then I'll go into a more interactive demo. So this is high level. You're going to import the executor from our Globus Compute SDK. We're importing a couple other things here, notably as completed from the concurrent futures module. I'll get into why we're doing that in a second. We create a function. This is sort of just a random function here. Notably, we're including the imports within the function. This is sort of important for how Globus Compute works because we're going to be serializing this entire function. So any imports need to be referenced or any dependencies need to be referenced directly in the function. And we'll submit some tasks. So we have the executor. The executor is modeled after the standard Python executor. So if you're familiar with that interface, it's very similar. With some notable differences like being able to specify an endpoint ID. We then are compiling the futures here, and we are calling gc.submit. This is where we include the callable. Again, very similar to the Python executor. We have some arguments for the function, and we are then going to print the results, which this is a blocking call, as they are completed. So we can use things like as completed from concurrent futures because again, the future object itself is essentially a wrapper around the standard Python future with, again, very small differences, things like task ID and some other kind of metadata that we need for for keeping track of which result goes to which future, etc. And then, yeah, we can wait for the results to come back. So now let's go into a little more interactive example. If you guys are, well, I don't think you have access to these slides here, but if you wanted to type this in, you could follow along. I'm going to go through it pretty quickly, so it's probably best to just go do it later. But we do have this a public Jupyter notebook here that you can follow along. So I'm going to jump over to it now. I'm going to just paraphrase a lot of this text here. So I'll just kind of go to our first line of code here. So again, same thing, we're going to import the executor. We're going to use the tutorial endpoint. So we have a publicly available tutorial endpoint. It's we have some pretty low caps on resources there. It's not meant to do Bitcoin mining or anything. So this is just meant to submit some hello worlds and test out functionality. And Kevin's going to go in later on actually setting up an endpoint, but this is assuming you already have an endpoint running. We're going to instantiate our executor here, and this is where we specify the endpoint ID. Keep going down. We're going to define a basic hello world function, and we will submit. We will retrieve a future back. We have our future. And now there's two main calls we can call here. So .done is a non-blocking call that'll immediately return a Boolean whether the result has returned and is populated in the future. And .result is a blocking call that will block until we actually have the result. So we'll call done first, and so we see that we already have the result. And then we can check the result here. So hello, wonderful person. Very nice. We can also catch exceptions. So I will submit a function here that will intentionally raise an exception by dividing by 0. And the .result call will raise the exception that was originally raised on the endpoint and sort of has made its way back to the SDK now and raised within your environment. So we can use arguments. So in this case, we have just A and B here, 2 numbers, and we can submit that. We'll get our result. Here we're again going over what I've mentioned before. We're including our dependencies, our import statements within the function. So in this case, if we're going to import from datetime, if there's any other packages that are not part of the standard Python library, you need to make sure those exist in the endpoint environment. I'm not sure how much we're going to touch on that in this presentation. We can go over that in detail later, but we have many different, we have at least 2 tutorials in our documentation, pretty in depth on how to handle the different Python environments, container environments. There's many different ways to handle this, but yeah, obviously a requirement is that the packages need to be available in the environment, in the endpoint environment that you're running on, or the worker environment, I should say. So, oops, here. Oops. What's going on here? Okay. We will run this. Okay, we got our date back, and let's just keep going through. You can also call external applications. So assuming you're all familiar with the subprocess module within the Python standard library. So we can always use that to make shell command, execute shell commands. In this case, we're kind of creating our run shell command, Python function here. We also have a shell function class that sort of handles a lot of the commonly used scenarios here where we want to capture standard out, standard error. We want to redirect standard out to a certain file and only submit a certain number of lines from standard out, for example, if you have a huge, some huge content that's coming out of your command. So yeah, but you can always call external applications like this. So we're going to run without using the shell function class. We'll just use our run shell function here. And if you see here, we're defining a command and we're just running run and print. The run and print command or function here is just calling submit for our run shell and then entering the command that we enter. So that's all that's going on here. And so here we're getting a bunch of information from the tutorial endpoint host. Environment variables, etc. Kernel info. So yeah, we can run functions many times. So here we are. We are going to, I believe this is Monte Carlo to estimate pi, but I think the details of the code here are not super important. The important part is just that, kind of like what I showed in the previous example, is just that we're submitting a bunch of functions, we're compiling them in a list here, and then we're going to print the results. In this case, we're not using as completed. Maybe you don't need to do that. If there's going to be, if they're very similar run times for each function, there's probably no need to use that, but yeah, this is just for demonstration purposes. So I'm going to submit a bunch of functions and retrieve all the results here. And I can use that to calculate pi. And then we have a series of endpoint operations. So there's only a single example here, but we have a number of different things where you can get, yeah, you can stop an endpoint, lock it, you can do a number of different things remotely, or just get the endpoint status, which is something quite simple. All right, so that's that. I'm going to quickly go over just kind of what's going on here as I'm submitting this, and then I'll hand it back over to Kevin. So this is a very simplified version of what's going on under the hood. So on the left here, you have the compute executor. This is the client, the SDK, like I was just showing. On the right would be the endpoint running on your HPC system in the cloud, or any compute resource. And then we have our Globus Compute services in the middle. So we have our web service represented here, and then we run a RabbitMQ instance. So first thing we're doing is submitting tasks. We submit that directly to the API web service. The web service will then enqueue the tasks on an endpoint-specific task queue. The endpoint is a consumer of this endpoint-specific task queue, consumes the tasks, runs the tasks on workers depending on your configuration of the endpoint. So, the simple out of the box endpoint, as Kevin's going to go over, uses a local provider, so it's going to use local CPUs. If you're using Slurm, et cetera, we have a bunch of different connectors. We call them providers that connect to the various different schedulers or cloud providers, et cetera. So we'll execute the tasks, and then we will enqueue the results back to what we call a task group results queue. So every time you are using the executor, we automatically create a group of tasks to sort of logically organize the tasks that are being submitted. And then we have a subscriber in the executor. Every time you instantiate a new executor or create a new task group, we have a thread that's running and just consuming from that task group queue. We pull results down and populate the futures. Okay, I'm going to hand this back over to Kevin to go over endpoints.
All right. To sharing. Oh, I need to share, don't I? Aha. And Zoom, come on. Share, share, and share. All right, someone will know when you can see the endpoint installation from my screen, please.
We can see it.
Awesome. All right, so we have this documented in our website as well, the Globus-Compute read the docs.io. But in short, you can choose how you want to do it. Most users will probably use the PyPy route, which is simply pip install Globus Compute endpoint. If you are an administrator, you may appreciate the snapshots we provide in the binary packages for your OS. The usual pattern for installing those via Globus, the Globus repo, which we at the time of release to PyPy, we also release to the binary packages there. Your choice. But the next fun is actually using the software once installed. And so we create an instance with configure, and I'll show this in action in a minute. And that simply creates 5 files. And I want to point out at this point, does not create, no network connection is made. This is simply creating a directory inside .globus compute in your home directory, wherever you are, and populates the 5 files from the next topic. So we've recently done a move migration to all endpoints are templatable, which for those of you who are new to us doesn't mean anything. But what that means for now is the user endpoint configuration template. The second file is the file of most interest for making sure that your endpoint matches the resource you've installed it on. As in, if I'm on my local machine, I want to make sure that when I send tasks to my local machine, it only uses G1 or 2 processes, as opposed to all of my cores, so I don't suddenly flood my desktop when I'm playing around. Or if I want to, when I'm on a cluster with a scheduler, I want to make sure I'm using the Slurm provider, or make sure I'm using PBS, whichever is appropriate, or using this account or that account. That all will go into the user config template YAML J2 file there. We can talk about that a little bit later. But in short, you create the instance before you would register it with the web services, compute web services, with the configure command of the Globus Compute endpoint executable. And then you start it with the aptly named start subcommand. And so this would start an endpoint, and we'll show you the ID that it registered with the web services. And this is how you access this endpoint. And again, I'll show an example of this live. And now, what could go wrong when doing something live? But we'll show this live in a minute. So then to use that, it's just as the code example previously does, uses that endpoint ID in the executor. You define the function, and then with the executor, set the endpoint ID, submit it, and wait for the result. And Bob's your uncle. It works. For those who might be interested in installing compute as a service to others on their system, we offer a root or privileged aware a set of logic within the endpoint. Same configuration. The only difference now is that identity mapping file. And this is how you make sure, or how you assign users to come in from the Globus Auth environment to a local user on your host here. I think we say POSIX user to be precise about it, but i.e. when you're on some Linux host, who is a user that's actually going to be running the codes or running the endpoint. This is how you do it for the identity mapping, and we have got examples on our website of how to set that if that's not clear. This should match if you used GCS, the Globus Connect service. Yes, sorry, so many acronyms. The Globus Connect service, the identity mapping there, already exact same code, should be drop-in replacement if you want to share identities. But in short, identity mapping is the big difference between a root run, privileged run endpoint versus a user endpoint. So with that in mind, you start it up the exact same way and submit to it as a user the exact same way. But if you don't have the identity mapping set up, as in, or it is set up and your user is not actually a valid user on the resource. So I'm submitting to my university cluster and I've not talked to the admin and have not added me to the identity mapping for that host. Even though I have successfully sent a task or tried to send a task, I was not able to start a user endpoint on my behalf on that cluster because the identity mapping failed. That's a crucial detail. So what we'll do, this next example here, is talk about how we get there, what's happening behind the scenes, what does identity mapping mean? So at a high level, identity mapping is simply making a connection between one identity, who you are with your with Globus Auth, or who you are with your university or your organization's single sign-on service, to the local machine who has to have some user to run locally, mapping and identity. And what this looks like from the user's perspective, or the flow, if you will, of to the function executing, is the user will submit a task to that endpoint or tasks and specify some appropriate user endpoint config. We haven't got there yet. And that will, at the web services, recognize that we're talking to this multi-user endpoint, and will send an identity and specifically a user endpoint identity, which would be specific to what the user sent. And that identity ID is crucial because that identity, we do not know in the Globus Web Services what the local user will be on the cluster in question. So that's the job of the manager endpoint process, to take the identity mapping configuration, and before creating a user process, to map the identity to a local user, a local unprivileged user, and then after becoming that local unprivileged user, start the user process. At which point the user process then talks back to the Globus Compute services to say, okay, what are my tasks? And send the results back to the Compute Web Services to complete the previous diagram of showing me the flow of tasks to the endpoint. This is a crucial detail difference between the multi-user and not multi-user of that changing who is running the user endpoint process. In fact, we take pains, unless the administrator really wants to do it, to not let the manager endpoint process run as, not let the user endpoint processes run as root. Because the manager endpoint process is a glorified process manager. The user process is what actually does the handling and running of tasks on the nodes. Hence, the privilege separation is important. So, an example of Reed and I both work with Globus and are out of UChicago. Here is an example of the identity mapping configuration. We will take the identity being passed to the manager endpoint, which is going to have something at uchicago.edu. And it's going to say, okay, look at that match there. It's a regular expression. Anything that is suffixed with an at uchicago.edu, we're going to assume the front part of that is a valid user. And then from the output there, this is a regular expression, so that parenthesis means capture a group. We're going to capture that first group, or C-base think the 0 group, and the output there. And the result then would be, in my case, Huntiki. In Reed's case, I'm not sure, but we'll call it Reed. And if Reed were to submit this, that identity would come through to the manager endpoint process. It would see read at uchicago.edu, lop off the at uchicago.edu, and be left with simply the output of read. Now, hopefully, if that works now, the local cluster or local configuration has a user read, in which case that user read is who ends up running this process, identity mapping. So we try it again with that identity mapping configuration set up, and nominally works again. Example aside. Okay, templating. So I talked a while back, I'll go back here and show that a file that was so fun, interesting is the user config template YAML file. That's what we're looking at now. And this is what allows you to change on the fly what a user runs, especially important for multi-user setups. So in a multi-user setup, then you are interested in possibly an account. So in this case, I might be on the left side of the template, on the right side, what the user sends in the SDK. The left side is what the administrator would have put into the user config template. And the two variables that can be set are the account ID and the wall time based on the double brackets there. This is Jinja's syntax. The wall time has a default, does not need to be specified, but can be. The account ID must be specified or will be empty or won't work with the Slurm provider. So when rendering this template, the template will look for those two variables. If those two variables are passed on the right side, when the user specifies the user endpoint config, they'll be put into this template, and that was what will be sent and given to the local user endpoint process to start. So in this case, the Slurm provider would be given the Pi account ID and wall time of 2 minutes. I'm going to stop right there. Kind of gone really quick. Any questions so far? I'm seeing nothing in the chat, and you're all. This is a good time to reach out and ask questions if you have any questions. All right, we'll call it good. But feel free to speak up now if we have more questions going forward here. So this is the next half for administrators. Again, we're in the root at the example of templates can put anything the user puts in there. How do you verify the account ID actually is a set of numbers which look like what account IDs look like for your platform as opposed to something else, or a wall time that looks like a wall time or not? Enter one of the other files I ignored earlier called the schema. And much more of important when you're an administrator offering your resource to somebody else as opposed to a user who may or may not want to use the schema, although it is helpful for debugging. And so in this case, as opposed to the number we sent earlier, this schema on the account ID is limiting the account ID in the user config, user endpoint config back to the left there, the user endpoint config, the account ID must be a string, and it must be one of the two, Pi Gibbons or Pi-Lumberg. PI. If it's not one of those two, apparently this schema will not allow any other account ID specified in the user endpoint config. And similarly, for the wall time, it needs to be a very particular regular expression pattern, which matches any time between 0, 0, 0, 0 and 1 hour, 59 minutes, 59 seconds. Lots of examples of how to dig into schemas to validate what the user may specify in the user endpoint configuration. But we'll stop here for this example. Do you want to take back over here, Reed, or shall I keep going?
Just keep going. I'm responding to a question in chat. That's fine.
Okay. So there are a couple of ways to restrict access to the multi-user endpoints or just endpoints in general. If you are a non-power user and you start up your endpoint, you don't have to worry that the only person who can submit to it is going to be your identity, and you'll see that go by the logs of the endpoint itself, and that's the end of it. If you start up your endpoint as a power user and are offering your endpoint to other users, you have a couple of options to enforce that only those who you want running code on your machine can run code on your machine through compute endpoints, this compute endpoint. The most directly applicable to the machine is the identity mapping we talked about earlier, the second point here. And that is completely up to the administrator how they assign that. We've got a couple of routes available. There's the regular expression-based mapping to check that user is allowed. The other one is an external. If you need something more complicated than simple regular expressions, you can have any executable you want, take the identities and return which one's valid or not, and then use that to create a local, to discover the local POSIX user. Additionally, you can also use authentication policies. This is a wider Globus offering about setting up who can log in, what, when, and from what domains. And this way, before the start user endpoint requests are even sent to your endpoint, they might be stopped or authenticated or allowed via the Globus web services. Something a lot of administrators want to know is how to restrict who can use my endpoint. Well, one of those folks you allow. Additionally, many folks, oh no, we're talking about authentication policy first, pardon me. So one of the ways to set these up is strictly from the command line. You can do it. Here's an example. We also have this in our documentation. Another way is to go through the web UI and create these directly. We have some description or documentation again how to do that as well. But in short, there are a couple of routes to set up an authentication policy. Additionally, sometimes you have an endpoint and you only want certain functions that you know that users may run. And simply put, you add those to the configuration, and now the endpoint will restrict and verify that only these are functions are requested. Any request to run a function that's not in this list will be rebuffed. Many folks are very concerned about who can run what, when, and where. This is one of the controls we offer. Another option, which is very pertinent to root run services, is to not have to manage it yourself, but to let systemd do that. And quite simply, it's a systemd unit file, and put that in the right place and tell systemd to start it or stop it. Looks just like this. You enable on boot and it will write one for you. Alternatively, you can write your own version of this and put it in the usual file. In short, usual systemd unit file administration. Any questions so far? Oh, they're being answered in chat, so I'll assume that's a good spot for it, but if you have something that's verbal, please just speak up. So I mentioned policies. An additional layer, and this is a feature, wider offering of Globus in general, is high assurance features. Globus Compute endpoints do opt into some high assurance features. One of them at the policy level is ensuring that when either the endpoint starts up or folks submit to the endpoint, that they've authenticated with a specific identity within a session as opposed to one of many linked identities that happen to include an allowed one. You can also isolate which applications are allowed to use your, if you have more just users, but applications use your endpoint. Additionally, the high assurance ensures that encryption across the board, across the entire chain is enforced. We also offer for HA subscribers that the endpoint will further audit who's run what when and what the status of those tasks were. Additionally, HA features also let you do multi-factor authentication if somebody wants to authenticate, not just the last hour, 2 hours a day, but also have done so with a second device, who they are, who they say they are. Additionally, high assurance also via the Globus Auth follows number of standards. I will leave that to probably Susan and or Lee and others to talk about the specifics of those standards. If you're interested in high assurance, now the key ways of doing it, you can do it from the command line, or again, you can read the documentation, Globus Compute endpoint documentation. We also have plenty within the Globus ecosystem in general. But in short, you're looking at adding the description ID, the high assurance subscription ID, and saying, not only is this compute endpoint associated with this high assurance subscription ID, it is also itself high assurance. Please enforce that everything comes through here is high assurance. And so now the endpoint itself, knowing that, will enforce the high assurance aspects of it as a service provider. And what that looks like after you've run the configure configure command is that file down below. It adds those two options two keys to the YAML file, whichever works best for your workflow to set it up. When you have an HA endpoint, you can also register HA functions. An HA function is associated with a specific HA high assurance endpoint. And HA functions that functions that are registered as high assurance, we will remove from our services entirely so that it can no longer be referenced or utilized after 90 days of no one using it, a garbage collection, if you will. And the point being is, no matter what you include in that function, we will not only handle it responsibly, we'll remove it responsibly. So you can be sure that it's gone after 90 days. For administrators mostly, but for anyone, if you're going to install a compute endpoint, the only ports that it needs for communication are port 443. You can optionally use port 5671, which is the AMQP, how it talks to RabbitMQ, but port 443, and it talks to strictly compute services, two different hosts, two different DNS names, the Compute API Globus.org and Compute AMQPS Globus.org. I don't have that exactly in my head, but also part of on our documentation in the installation requirements. And specifically, this does not listen for inbound connections. It makes strictly outbound connections to our web services, which is often of interest when installing this on somebody else's system or as an administrator. You will also need to have access to some sort of shared file system if you're on a leadership class, well, a cluster in general, and a scheduler. The scheduler might be simply your local kernel. It doesn't have to be a site-wide scheduler, but it has to be some scheduler of some kind. You have this pulled up. Do you want to show what this looks like, Reed? In practice?
Yeah, I can do that. Yep.
Okay. So this is the administrative console. This is a relatively recent addition to the line. If you're an administrator and have your associated endpoint with a subscription, you can see who's running what on your endpoint via the Globus app administrative console. When you're ready, I can relinquish control and show live who's running on our tutorial endpoint or who recently ran the tutorial endpoint. Each of these rows indicate a user-specific endpoint. You might have two. So if somebody changed the user endpoint configuration, you might have multiple rows for one person on your endpoint. And these rows will stay here for a time afterward until they are eventually garbage collected and removed until the user runs the endpoint again, as in submits a task again. You ready, Reed? Or?
Yeah, I think I'm screen sharing already, actually.
Oh, well, I'll stop sharing myself.
All right. Can everyone see my screen here? I'm showing a Globus web app, I believe.
That looks like yes. Thank you, David.
So So yeah, there's two different places. Kind of, if you are in the Globus web app and you go to the compute section, you'll see a list of, in this case, most of these are publicly accessible endpoints. So this is stuff that I could use. I'm actually going to use this as an Anvil as an example in a second. This is a multi-user endpoint running on Anvil. But for admins, if I go to the admin consoles, if you use transfer or search, you're probably familiar with this section here. But I can go to compute, and here are a few multi-user endpoints that I have admin access to. So I'm going to go to our tutorial endpoint just as an example. And I can see that some users, maybe some of you guys, or maybe not, but have submitted functions to the tutorial endpoint. And when you do, we launch a new user endpoint process. We have the local user name. We're automatically generating these based on the user IDs. We have our process IDs associated with each one of these user endpoints. And I can go into one of these. Let's go to a recent one. And I can get some more information here. I can see how many workers are running, what the worker utilization is. If this was a large task, depending on your configuration, you might have many workers, many nodes. And yeah, I can see the configuration that was actually rendered. So in this case, it's very simple here. I don't believe in our tutorial endpoint we have any Jinja variables, but if you did here, you wouldn't see the template, you would see the final the rendered config. Let's see, endpoint version, yeah, so just some other useful information here to monitor your multi-user endpoint. I think I should jump probably right into just running a function on Anvil. Is that right, Kevin, at this point? Yeah, okay. So like I just mentioned, just to kind of demonstrate this, Anvil is running a multi-user endpoint, and they are part of they use access resources. So if I can just kind of show what this would look like. So I'm going to copy the ID here. Again, anyone who has a Globus account should be able to log into globus.org, and they should see probably a similar list. I have some CRUD in here that from testing, but they should probably see a somewhat similar list, at least at the top here, because many of these are publicly accessible endpoints that you can submit to as long as you have a local user account. So again, I'm going to use Anvil here. On the basic page here, I can see some simple things. So like the user config schema, this is going to show me all of the different variables that I can specify in my user endpoint config. I'm not going to, for this, for the purposes of this tutorial here, I'm not going to specify any of these, but if you are a user who is submitting to Anvil, this is what you would want to reference here. And because it's a JSON schema, you can include things like comments and various constraints that you should follow. As Kevin mentioned, this entire schema will be applied to the variables before the template is rendered. So these will be enforced, but you can also just reference them ahead of time to make sure that you're falling within the constraints. And yeah, here's the template. So again, anyone can see what it actually will be rendered. And this is the manager process configuration. So yeah, just some high level stuff here. So I'm going to go back to our Jupyter Lab notebook here, go all the way to the top, and instead of the tutorial endpoint ID, I'm going to paste in the Anvil endpoint ID. And I will instantiate my new executor. I have my new endpoint code here, and I'm going to submit a function. Now, I believe Kevin already covered this, but on first submit to an endpoint, you're going to, there's going to be some delay to just start the new user endpoint process. If it's a busy machine or if it's under-resourced, it could take a little while. So I'm not sure exactly how long this is going to take, but so you can see I haven't returned the result back. So we'll give that a moment. Yeah, once the user endpoint is up, then it's a matter of, should be seconds or even less than a second to submit the task, have it pulled down to the endpoint and return the results back. So give that a moment. Yeah, it still hasn't finished yet, so Anvil might be a little tasked right now. The other thing, while Kevin was going over this, and actually while I completed this, I realized that I didn't cover a new feature that we don't have in our tutorial here and we don't have in our presentation, but I think is worth calling out. But just while I wait for that for a second, I'm going to scroll down to where we import dependencies. So the typical interface in order to submit a function is that we insert a callable here. And so when you're doing this, we have There's a number of serialization strategies, and there's a lot of stuff we could get into on how this is actually being done. But you can think, if you're familiar with pickle or dill, which is more accurate to what we're actually using. And there's a number of other serialization strategies we use, like just reading the direct source code, using text inspect, and a few other things. But the interface expects a callable, and then your data or your arguments that you want to submit with that function. We do have another interface that we've implemented recently, and instead of just submit, I believe it's called submit source code, or actually it's register source code. So if you're if you didn't want to use the executor here to submit, and you already had a function in the web service, you could use another method called submit. So it's not going to autocomplete here, but it's submit to registered function. So let's say you had a function ID, and you know, it's already stored in the web service. There's no need to re-register that function. You can submit to that specific function ID, or with that specific function ID. Where this is most useful is if the endpoint has a function allow list, like Kevin went over. So if you have specific function UUIDs that are specified in the allow list, obviously you need to be able to, you know, specify which function ID that you want to actually submit. And so you wouldn't use the normal submit method here, which is going to register a new function essentially every time you launch a new Python process. You'd want to use submit to function ID. So if you're going to use that methodology, you can also, instead of registering a function in the normal interface we have here, you can register source code. And the difference here, and why that's important, is that you can essentially paste in any text string. So let's say you had like a workflow file, and you know, it's not all wrapped in a single function. You had your imports outside of the function. You had decorators. You had you know, a number of different functions that you wanted to call. And then you have one entry point function at the bottom. Let's call it main or something like that. That's going to run the entire workflow. You could actually just read the contents of that file, register the function with the register source code method on the executor or our client. Again, I'm probably giving too many details here, but you could register that and submit that to the endpoint. This is also popular for people who ever run into any weird serialization issues. So if you're using strange Python objects or something that for some reason is causing serialization issues, we sort of implemented this method to be a sort of a workaround for that, or just really another way to interface with compute. But by and large, definitely the majority of people, or almost all of our users that are currently using compute, follow this standard interface here, and they find this to be the most useful. But anyways, just wanted to call that out. We can get into that more if you guys have questions, and I can maybe do an actual demonstration. So let's go back up here. Hopefully this is done. Yeah, okay. So the function is done. And now just to show that because that endpoint is now online, if I submit another one, this should be fairly fast to return, unless I waited too long and my endpoint is down. But anyways, this is just a demo of showing us actually submitting to access resources. So yeah, I think I waited too long and my user endpoint shut down. So there's also another thing to mention. There's a timeout, a configurable timeout that you can, in order to just kind of keep the memory footprint low, you can set the timeout really low. It's possible Jeffrey Lettner is the admin for Anvil, might have reduced that to a small number. So if you're continuously running functions, it'll keep the user endpoint process online. But if you submit one function and if you set it to 10 seconds or something, then the user endpoint process would shut down. And you'd have to re-up it again. All right, Kevin, did you have anything else you wanted to go through, or more or less?
I think I was going to show a live starting configuring an endpoint, but I also don't have to, but we can do.
I'll wait for time. Yeah, can stop
All
sharing.
right, let's see, share my screen again. And so what I'm going to show now is just that we weren't lying to in the presentation, and what it looks like to show a that's my screen. Good, we're done with that. However, let's go to here. All right, just confirming, can folks see my terminal?
Yes.
No?
Yes.
Okay, awesome. Okay, fantastic. Okay, so
It's sort of overlaid over your slides.
yeah, which I probably stupid on my part to have done. I have
It's
transparent
readable.
terminal.
It's okay.
Okay, good. Now my font is, there we go. That's better. Okay.
Yeah.
Okay. Keep going back and forth. God, I am having issues. Okay. So, I'm going to configure a new endpoint right now. Globus Compute endpoint, configure, access, talk, EP. And my large font notwithstanding, can folks see that? Is that too small to see?
No, that's okay. That's fine. That's okay.
Okay. So just as on the slides there, I will go ahead and look at this directory to show what it looks like in reality. And just those 4 files. And I'm going to go ahead and start this endpoint, Globus Compute endpoint, start, access, talk. Actually, first of all, I'm going to, you know what, I'm not, talk EP, and it should immediately register. There we have it. So there is the endpoint ID. I'm going to take that and I'm over here, and from Globus Compute endpoint, Globus Compute SDK import executor, let's create a function. Let's see, let's do sum for my sum, or dot product. Here we go. Some on the fly thinking, which is not good. I'll call you a list, and B call you a list. And let's see, then I'm going to return the summation of what I times j for, no, it's not right, for, yes, I comma j in zip A and B. So idea is to go along each of these lists and pull out the nth item and to multiply them and return the sum. I think it's dot product. It's been a while since I've done physics math. All right, with executor then, as the executor, we're going to set the endpoint ID equal to the endpoint ID from over there. I'm going to, I guess just submit it. Future is equal to submit dot product, and let's do the dot product with, we'll do 10 to 20. Okay, so if I've got my math right here, you know what, let's not be too complicated. We should multiply 0 times 0 plus 1 times 1 plus 2 plus 2 plus 3 plus 3 times 3, and let's see what happens. And then print f dot result. Okay, and oh no, what did I do wrong? I didn't close that one. There we go. Okay. So cross your fingers that I haven't lied to you, and we'll come back in a second when the endpoint starts up, or we can also show what that looks like over here. Okay. Yay, good. I wasn't lying to you. So that took a second to set up on my own machine here, as it verified who I was, and I was not a root user when running it, but there we have it. Pretty quick to set up, but only for me as the developer, but hopefully not too scary when watching the whole thing. Oh, that was the whole interaction. I think that is our presentation. Now is a great time for questions or poking the bear and seeing what comes up. Thank you for your time.
Great, Kevin. So we have a few minutes here. I think there's one question in the chat. How is this connected to Globus flows?
Lev, are you on the call? Do you want to take the one, put you on the spot? I think you could brilliantly articulate that.
I could do it. It's really not connected in a sense that other than being just another Globus product, I think. So flows is just an automation that executes steps in sequence under control and orchestration of Globus Flow's service. So compute can be a step in that sequence. one step or multiple consecutive compute steps. Just like any other step, it can be, minting a DOI or doing a transfer. So flows is, I guess, higher level in a sense. Does that make sense?
I assume that's what he's asking for is like, I mean, so there's a dedicated compute action provider if you're, familiar with the flows ecosystem and everything. So yeah, it's very common. There's a lot of people who have flows who do multi-compute steps, transfer data, then run some compute, return the results, transfer the results to another GCS collection, etc.
Great. Any other questions?
And if not now, if you have others, feel free to reach out to us in the FunkX Slack, our Genesis, if you will. We were rebranded to Globus Compute a while back, and that is linked, I believe, in Globus Compute, Globus Compute Read the Docs IO. And if not, somebody tell me I'm wrong, and we'll go from there.
We did get one last question here in the Slack.
Yeah, I just read through that. So we have a number of endpoint configuration examples in our documentation. I'll actually paste a link in here right now. But it's easy enough to find. If you go to Globus Compute Read the Docs, and it gets under endpoints and then example configurations. We have Polaris. We have a number of different example configurations to get you up and running soon. But if you're going to run a multi-user endpoint, then you do need either root or some privileged user access. So yeah, you're going to have to involve an admin for that. But for a quote unquote single user endpoint, you can get up and running quickly. Submit to function ID method. Yes, I can. So yeah, someone just asked about linking to the submit to function ID method. Yeah, and also
that.
Yeah, if you don't mind that. And I think really what he's referring to there is actually the probably the register source code method is kind of the more important thing there. We have a pending tutorial on using this. There's some examples in like the doc string of the method. It's a new thing that I forget when I implemented that a few weeks ago. So, and we're actually likely going to on the roadmap just move that all actually directly to the API because there is a desire to just submit functions directly from web applications without involving the Python SDK, which requires serialization, et cetera. So obviously this is on the submitting client to make sure that the code is correct and won't error out, but it does it simplifies this a lot, especially for like JavaScript applications, et cetera. So I think Kevin just posted that in there.
Is there any logging to tell what stage the compute is in? For example, can I tell if my job is waiting for Slurm to schedule without logging the head node running scount, or is it currently running? I don't think this is as flushed out as we would like it. Yes, there is. It's in the state of it is logged in respective logs within that tilde Globus Compute in the endpoint. But if you don't log in to see that, we don't have a great way at the moment of, oh, did someone just answer that for me, or is that something else? Nope, it's a different conversation. So it's not, the answer is it's not beautiful. It's logged somewhere, but we have not flushed out how to get that particular information cleanly while you're sitting at your computer not logged in.
Just to add to that, though, like on the endpoint itself, I mean, if you're digging into the endpoint logs, you can see when jobs are submitted. We have submit scripts, and so I think we'd have to get into quite a bit of detail here. If you're familiar with Parcel, Globus Compute is built on top of Parcel, so every time a job is submitted to Slurm, this is not on a per task basis since this is a pilot model. You have a single job that's created. We get a bunch of nodes, and then there's a number of tasks that will be submitted to that single job. But yeah, on a per task basis, I mean, that is something we're like currently working on, trying to get more task visibility and control over individual tasks. We kind of right now consider it once you submit a task and it's in the web service, it's kind of like it's because it's hard to tell exactly where it is in the sequence here. It's it's essentially running, you could say. So. I think there was another question that popped up. It's a little weird how Zoom does the chat here. Allow using Globus API.
Okay. I think that's the questions. Anything else? Feel free to ask verbally too.
Right. Were all the questions answered?
I think so.
Okay.
There's one more, it looks like. Oh, that was useful. That's not a question. Thank you, Brian.
All right. Well, thank you
Feel
very
free to
much.
put in praise in there too, guys. That's fun too.
Thanks, Reed. And with that, the recording will be posted soon, but thanks everyone for joining.
Do reach out. I
Thanks,
personally
everyone.
view myself as a glorified plumber. So if it's not working, we want help. Reach out. We want it to work for you. We really do.
Yeah, I second that.